Hello, Madrid. Thanks for having me. I have a lot of text on my slides. I'll share them after, I promise. I'll probably get flagged down at the very end to speed up. So let's dive right in. So we're going to talk about powering multi-tenant applications with Nuxt. And let me get this fixed real quick. There we go. So again, I'm Adam DeHaven. I'm a staff software engineer at Kong. I work with anything from component libraries to our developer experience, micro front-ends, which I think you're going to hear about here in a little bit. And yeah, so let's jump right in. So what is multi-tenancy? So it's usually an architecture where a single application built once serves multiple tenants or organizations. So a few common examples you might be familiar with are SaaS platforms like CRMs, project management tools, where each customer gets their own isolated workspace within the same application infrastructure. E-commerce platforms that power multiple storefronts, private label solutions where clients can customize platforms with their own identity, design elements, such as developer portals or dashboards. And also enterprise ecosystems where large organizations have multiple divisions. So all these examples share the same principle, which is one code base serving many distinct customer experiences. So let's dive a little bit deeper. So with multi-tenancy, you typically have a shared infrastructure and a shared code base. So the app is built and deployed using a single code base, which reduces maintenance over time, reduces overhead, and ensures all tenants benefit from the same features that you build into the product. Typically, they have isolated tenant data, right? So this is usually achieved through a combination of storage partitioning and application-level access controls. The content in UX is customizable per tenant, so tenants can fully customize the content, layout, and visual elements of the app, creating a unique branded experience for their users. Typically, benefits of this are easier maintenance, cost efficiency, and consolidated monitoring and reporting. So you can easily aggregate data across your tenants for analytics and insights, which can be beneficial for product development and like your marketing groups. So typically when you have more tenants, you get more complexity, right? So you get things like handling tenant-specific content configurations, maintaining separate branding and UX per tenant, managing different authentication strategies and authorization across tenants, and also ensuring performance with varying traffic loads, right? You may have some tenants with 100 users and some with 100,000. So many teams end up with separate code bases or end up needing to do separate builds for each tenant, which can quickly become unmanageable and very, very expensive. But what if you can maintain a single code base while still delivering fully customized experiences for each tenant? Well, this is precisely where Nuxt architecture shines. So Nuxt makes it easy. So Nuxt, along with the Nitro server, provides a robust set of features and capabilities that make it an ideal choice for building scalable, maintainable, and customizable multi-tenant applications. So let's walk through some of the key features that make Nuxt a great choice for multi-tenancy. So first, runtime configuration. So it allows for dynamic loading of tenant-specific settings and features. There's no need to rebuild. There's no need to redeploy with different secrets. It's all done at runtime. The next is the built-in Nitro server engine. So plugins, middleware, and event handlers enable Nuxt to seamlessly read and write to storage providers that can all be tenant-aware, as well as interfacing with external APIs and tenant-aware request handling and caching strategies. The Nuxt module ecosystem, right? We're all familiar with Nuxt modules. They easily extend functionality and can add tenant-specific features to the app based on a dynamic configuration. So then we can talk about server-side rendering and SEO, with built-in head management for tenant content and metadata, and then edge deployment capability. So everything with Nuxt can be deployed at the edge, which dramatically reduces latency and enables powerful caching strategies that automatically scale. So to get into multi-tenancy, well, first we have to know which tenant are we trying to serve, right? So before we can customize our application, we have to detect which tenant is actually being requested in the browser. So this is typically done on the server by examining the initial client request. This is where a Nitro plugin or middleware comes into play. A typical multi-tenant setup utilizes a single deployment, separating tenants via subdomains or through custom domains mapped via CNAME records, right? So for example, if you access tenanta.app.com, we can infer that they are requesting this particular tenant's application, and we can then fetch the appropriate data and configuration for that tenant. So let's dive in and write some code. So to get started, we'll create a few helpers that are going to help detect the requested tenant. We'll create a custom fetch instance to make API requests from the client while automatically attaching request headers. We'll replace the usage of fetch and use async data calls with a simpler composable. And finally, we'll create a Nitro plugin to extract the tenant info from the request headers and add it to the event context, which makes it available to all server routes and middleware. So first, let's create our custom fetch plugin. So this will be used to make all API requests from the client to our Nitro server. It'll allow us to attach these custom headers and then eventually route everything through a catch-all route on Nitro where we will proxy requests and access our storage provider. So first, we'll create our new file with our fetch plugin, access some built-in Nuxt composables, create the fetch instance, which will be used to proxy all the requests through a Nitro route that we'll set up in a bit. In the onRequest hook, we'll pass along the original client request headers. Most importantly, we'll add our tenant-specific headers to all requests so we can identify the tenant on the server. So what we're doing is grabbing the original request URL from the client request, attaching it to a custom header that our Nitro server will then look for on the back end. And then finally, we'll expose our custom fetch instance to the Nuxt app via provide so that it can be used in all of our components and pages throughout the app. So now that we have our Nitro fetch client initialized, we can leverage it inside use async data and pages and components to fetch data from our server. So first we import it from use Nuxt app composable. We then create a reactive key for use async data, shout out 3.17, I think, maybe 16, yeah. And this will ensure that when the route changes, the data will automatically be refetched. And then we finally call our API instance with the endpoint we want to hit and pass the route path as the parameter. So this will automatically attach our custom tenant headers to the request. So now that we have this, instead of using async data and API directly, right, having to wrap that in every component and reuse it, we'll actually create a new composable, use API, that wraps Nuxt's built-in use fetch method, and it uses our custom API instance. So next, we'll take our previous code that was using our API instance wrapped by use async data, and we'll refactor it to utilize our new use API composable. So now our component code is much simpler and automatically handles the tenant detection for us. So now that we've identified the original client request, we can access them on the Nitro server to identify the tenant. So let's create another Nitro plugin to attach the tenant info to the event context so that it's available to all our server routes and middleware. So again, we'll create our Nitro plugin file. So like here's an example, server plugins, and then tenant context. And you notice the 00 at the beginning, right? You can do your name, file name-based ordering of Nitro plugins. We'll hook into the request event to get the original client request headers. We will grab the tenant host name from our component request, which is captured in the plugin, along with the original host header. So the host name will be used to determine the tenant identity when accessing our storage provider and can be used later to look up tenant data when proxying requests to APIs. We can then utilize the host name as the unique part of the key in our storage provider to look up the tenant's ID. So for example, here we're using KB storage, and we use the tenant :ID and then the actual ID to get that data from our KB store. And finally, our tenant data is attached to the event context, again, making it available for any further routes and middleware. So we can also augment the event context with H3 to basically include this tenant data, right? So since we're attaching custom data to the interface, we can just simply augment the H3 event context to make that available on our TypeScript project, right? So we can easily tell between our server files what's available. So now that we've identified the tenant, we now can use that tenant's unique identifier, which in this case is the tenant ID that we just retrieved, to fetch or store data on the edge in a tenant-aware manner. So let's say we want to fetch the tenant's theme name from their configuration data and add it to the head of our application with another Nuxt plugin. So first we create a plugin file that we can use to fetch the config data and add our theme attribute to the head element of the page. So we'll fetch the tenant config using our use API composable. We'll use the use head safe composable to add a data theme attribute to the root HTML element. The data theme attribute can then be utilized in our CSS to apply the style rules for the different theme, right? So if my theme is midnight, these rules apply. If I'm in the default theme, here's the other styles, right? And so next, let's create that config endpoint on our server. So we'll set up a Nitro server route that will handle the config request and use the tenant's ID to fetch the appropriate data from our storage provider. So for our example, we'll assume that each tenant's configuration is stored as JSON in our KB store. And the key format will be similar to before, where it's tenant :config :ID, where the ID is the unique identifier. So to get started, we'll create the new file and create an event handler that will retrieve that tenant's configuration. So first, we'll grab the tenant info from the event context that we set up in our Nitro plugin. We will then use the tenant ID as the unique part of the key, retrieving the configuration object from our KB storage, similar to what we did before. If no config is found for the tenant, we could also throw a 404 error. We could optionally fall back to fetching this from an external API, so you have some options there. And then finally, we'll return the config object as a response. So this is great, but we're doing this at runtime, so this is going to be a little bit expensive. The more things you add, the more things you fetch could potentially slow down your app, right? So we want to refactor this into a cached event handler in order to greatly improve the performance. So we're going to refactor the event handler to use define cached event handler. That then allows us to pass some additional options for the cache. So we can create a cache key based on the unique tenant ID. We'll set stale while revalidate to true to serve a stale cache response while asynchronously revalidating the data in the background. You could also automatically refetch if it changes if you want. We'll set the max age to, let's say, 1 hour. And then most importantly, we set the varies option on the cache to basically include any headers that we want to consider for the cache. So if you don't, let's say, vary that host name, it's not going to vary between your cache requests, and you're going to end up with some potential data pollution on that side. So in larger apps, right, so we can already talk to our storage provider, but we may need to be able to proxy request to an external API that's also tenant aware. So now that we've identified the tenant, we can set up a proxy handler, also on the Nitro server, to route requests to our external API. So for our example, we'll assume that each tenant has an external API that's maybe served from a different subdomain, and the tenant ID is in the request path to fetch that tenant's data. So we're going to set up a catch-all route in Nitro that'll handle the request to this external API and automatically inject the tenant ID into the request path. So to get started, once again, we'll create a catch-all server route at server API external. And you notice the file format here, right? That's essentially, it will catch any request on our Nitro server that goes to any path in that chain. So we will construct the target path, right? So this is basically the path-based portion of our request by removing that external prefix that we're going to use. We'll set the request target utilizing our external API's base URL. So you can see here it's api.app.com. And then we use the tenant ID from our event context to join that path. We then determine the request body and then set up the send proxy function to be able to pass along any additional headers that might be needed. Finally, we can add additional fetch options to the send proxy function to set the request method, body, and anything else you need to send along. So in more complex applications, you might proxy this to the same origin. Maybe your API actually lives on the same origin and you have a different setup. So again, you can use that event context to grab whatever data you need to forward that request. So now that we have set up our proxy route, we can use it in our pages and components to fetch tenant-specific data from our external API. So here in this example, we'll fetch a list of users from the external API from that external route that we just created, right? So we can see that we are just simply hitting the endpoint with users, and the wrapper that we added will automatically inject that tenant ID, so we don't have to worry about it in our pages or components. So now we've identified the tenant, we can fetch our data from storage providers and APIs, and so now we're actually ready to let our tenants customize the app, right? So keep in mind the data critical of the app should be cached, should be fetched when the initial request is made during SSR. And so again, you want them to be quick, you want them to be performant, and you want to make sure you handle that with proper cache handlers and things like that. So let's begin customizing our app. So Nuxt modular architecture and runtime configuration capabilities are perfect for a multi-tenant application. So it allows us to dynamically configure Nuxt modules and other configurations based on the tenant without having to rebuild the entire app. So using a couple Nuxt modules as examples, we can do things for SEO, right? We can configure tenant-specific page titles, description, and open graph data based on the tenant's page data. We can also generate origin-specific sitemaps and robots.txt files. We can enable tenants to configure third-party integrations, such as Google Tag Manager, to track user behavior and other metrics based on IDs. Similarly, tenants can also integrate with their own error monitoring, like Sentry or something similar, to capture and report errors and performance issues. So remember, our core app doesn't have to care about any of this. All we have to do is create an integration. The tenant configures that integration, and it's essentially a seamless experience. So we can also dynamically control which features are available to each tenant at runtime. So for example, the ability to create new users, access certain pages, or use specific features can be toggled based on the tenant's preferences, subscription level, A/B testing, or product-driven feature flags. So the approach is the same for all integrations. You expose the integration for your tenant, determine the active tenant, access the config via our tenant-aware storage and APIs, and then configure the modules at runtime based on that tenant's preferences or other criteria. So now that we've configured the app for the tenant, it's time to customize the look and feel of the app, right? So this is typically the biggest piece of like a multi-tenancy experience where each tenant wants to be able to have their own branded experience for their customers. So similar to how we fetch the tenant's theme name from the storage provider and added it to the HTML, we can also fetch other data such as, let's say, the tenant's custom style sheets in order to customize the look and feel. So we'll go ahead and modify our tenant theme plugin that we already created. So we've already retrieved the tenant config from our storage provider. We'll utilize the tenant's custom CSS from that config to add a style tag to that document head, where their custom style sheets will be loaded in. So this is where they can customize global colors, fonts, and other styles to match their brand, right? Other customizations can be made in a similar manner, such as adding other script tags for custom integrations or schema.org tags for SEO, etc. For other brand elements, such as the logo, we can easily fetch them from dedicated tenant-aware endpoints at runtime. So maybe you have a dynamic endpoint for the logo, the favicon, and other kind of similar common assets for each tenant, right? So you can fetch them from your tenant-aware endpoints, and everything just works automatically in the client. So now let's enable our tenants to customize the pages and the content, which is arguably the most impactful form of customization. So supporting this level of customization introduces complexity, which typically calls for an architecture designed with flexibility. So let's go over a few of our key requirements. So page content must be configurable by the tenant in an easy-to-use format, right? We want editing, creating, deleting content to be easy and seamless. The page paths in the app must be fully dynamic, right? So we want customers or tenants to be able to design intuitive navigation based on whatever their site structure may be. And the app must offer highly customizable components that can be used to build complex page layouts that seamlessly align with their brand identity, right? So when thinking out to solve for all these requirements, many of you may consider utilizing Nuxt content, which I'm guessing a lot of people are probably familiar with, which is a powerful CMS for Nuxt applications. So Nuxt content allows you to create dynamic pages and routes based on easily editable collection sources, such as Markdown files. With version 3, you can even source from a local or remote collection, including Git repositories, bringing us closer to the vision of our fully flexible, real-time application. However, it may fall short delivering truly live, on-demand content for all of our scenarios we've talked about. So let's extract some of the core functionality of the Nuxt content module to provide an alternative solution for our tenants that we laid out for our requirements that we laid out for the application. So first, we need the content to be easy and familiar. So similar to Nuxt content, we'll go ahead and standardize on Markdown as our content format, as it's widely used and easy to read and write even for non-technical customers. Markdown on its own is great. However, we want to support a more advanced syntax for our content authors. So this is where the Nuxt MDC module comes in. Under the hood, the MDC module is what powers Nuxt content to parse and render Markdown alongside Vue components, which provides a powerful and flexible way to create dynamic and customizable content. So from here on, we'll assume Nuxt MDC, that Nuxt MDC module is already installed and configured in our app. So now that we know that we're using Nuxt MDC to render content, we'll need to allow each tenant to organize and store their MDC pages via our API in a way that's easy to manage and organize. So again, we're going to allow MDC Markdown documents, essentially, to drive the content of the page for the tenant. So we'll provide API endpoints for tenants to manage their MDC pages in our storage provider, meaning they can create, edit, and delete documents at will, right? So this also requires a way, obviously, for them to authenticate and to authorize tenants to ensure they can only access their content, but we're not going to cover that in this talk. That's a little bit more deeper dive. Tenants will push their pages to the API, though, once they're authenticated or with their API key or what have you, mapping the file structure in their directory to path-based logic that'll render the page in the app. So for an example, if you have a file at about/team.md, it would be served at /about/team in the actual application. So we'll store this page document once pushed under a tenant-specific key. So for example, in Cloudflare R2, we'll use the tenant ID and then the page path as the unique key. So now let's go ahead and render the content in our app. So in our catch-all page component, first we'll utilize the requested path to fetch the page from our API. If the page is not found, we can throw a 404 error, causing our global error handler page to be displayed. Next, we will parse the page content utilizing the parse markdown function from MDC module, which returns an abstract syntax tree or AST representation of the document. Finally, we'll render the parse content using the MDC render component, which will take care of rendering the AST and any internal Vue components into functional HTML. We can also utilize the MDC documents front matter, which you can see here as the data, AST.data, to configure metadata for the page at runtime, such as the page title, description, SEO-related information, even like the OG image, along with the use head composable. It's not shown here, but it's all possible. And note a little bit, I've simplified this a little bit. You'll definitely want to handle errors better, loading states, things like that, but simplified. So now that we know that we've let them store their pages, right? So we now need to let them have complete control over the look and feel. So we'll provide a set of highly customizable components that can be used by tenants to build complex layouts in their MDC pages. So you could, and maybe should, if you want to get up and running quickly, use an existing UI library, such as Nuxt UI, which is great. Or you can build your own components. So just ensure the components are globally registered in the app so the MDC renderer has access to render them in the AST. So for our example, we're not going to use Nuxt UI. We're going to walk through how to build a simple page container component that can be used to create stylized containers such as cards, hero sections, and more. So we'll start by creating just a simple Vue component, just pagecontainer.vue, that'll be used as a primitive component for building page layouts. I apologize, I always put the template at the top. I know that's not the thing anymore, but that's what I do. The component accepts a set of props that'll allow customizing the structure and style. So we can set the HTML tag, the color, background margin, and so forth. So the props will then be bound to the component styles, allowing for easy customization. The component will use the MDC slot component from the MDC module to render any markdown content that's passed to the default slot. So this also supports child components as well, allowing for flexible and dynamic page layouts in our app. So now that we have this simple component, so again, very simple, let's take a look at how our tenant can use this component in their MDC document. So first, the tenant will add the page container component to their page document. So again, this document that I'm showing, it's just a markdown document. That's it. Next, the component's props are configured to achieve the desired look and feel. So notice here, importantly, that we're utilizing CSS custom properties to define the color, background color, border color, things like that. And you could extend this to any kind of, as far as your design system wants to be, you can essentially tokenize everything, right? So this allows us to have a single code base, a single component that can serve a wide variety of tenants that can then utilize that custom style sheet we loaded initially to further customize the entire look and feel of all the components that we offer, right? So finally, we can then add the slot content to render the desired markdown inside the container. So again, this content can be regular markdown. It can also be other MDC components. So the tenant now has configured their simple card on their page from our globally registered page container component, right? So easy. They can also nest components inside each other to create more complex layouts. So you could have an infinite scale of these page containers to just get super fancy cards with like 1,000 borders. Probably don't want that. Or we, as the application developer, can offer more complex components that utilize these primitives to make it easier for them to build their pages. So that's what we're going to do. So we're going to wrap our page container component to build something more complex. So here's an example of configuring a more complex component. Let's call it a page hero, which is internally comprised of several other MDC components, right? So internally it uses our page container, maybe a button component, and maybe an image wrapper, something like that shape. So the tenant can now simplify that card and customize the component's props along with multiple slots to create a unique hero section for their app, right? So this is the exact same page container component, wrapped it in a page hero with a slot for the actions, the header, and then applied some different styles, as you can see in the props. And taking this a step further, you can actually create an entire library of components, right, that cover a wide range of use cases that are fully customizable by your tenant. And keep in mind, you can have your own set and still use something like Nuxt UI. There's nothing to say you can't use both. It's just whatever suits your need, right? It's whatever you globally register, you can make available for your customers or users. So since each MDC component is customizable, every tenant app can have a unique look and feel while relying on the exact same core components. So you can really build anything that's needed. Primitive components like buttons, cards, and containers, product lists with search, interactive pricing tables, AI chatbots, charts and interactive visualizations. The possibilities are really endless, anything that you want to do. Because keep in mind, those MDC components can also do data fetching. They can also do anything that any Nuxt component can do. Okay, so let's recap what we've covered a little bit today. So key takeaways. Nuxt server architecture creates a perfect foundation for multi-tenancy. So you have one code base that can serve unlimited tenants with dramatically reduced maintenance. Runtime configurations let us customize everything dynamically, from branding to features, without separate builds or deployment for each tenant. MDC, with tenant-aware data retrieval, gives tenants complete control over their content, maintaining a unified code base. And remember, multi-tenancy doesn't have to be complex with Nuxt, right? So build once, deploy once, and enable your users to completely customize the experience. I want to give it a shout out to Nuxt Labs with Sebastian and Ahad for all the work they're doing there. I've tried to, so I work at Kong. We're using all this under the hood for our new developer portal. We're trying to contribute as much upstream back up to Nuxt Labs that we can. And also for Daniel, he's saved us a couple times on some different issues, so thank you while you're here. But anyway, that's it for me today. Thanks for having me in Madrid. Here's a link to the slides, and you can reach me any of those socials.